Hello everyone, and welcome to today's presentation on protocol architecture in data communication and networks. And we are saying that protocol architecture, this refers to the structured framework that governs how data is transmitted and received over a network, right? So this is a set of rules and standards that define how devices communicate with each other over a network, right? Benefits of this protocol architecture, and the benefits include scalability. And when you're saying scalability, we're talking about we are saying that protocol architecture allows networks to scale easily, accommodating new devices and applications. So it supports network expansion without significant redesign. You can talk of error handling, and protocol architecture provides mechanisms for error detection and correction, ensuring reliable data transfer. So this provides mechanisms for detecting and correcting communication errors. So there is efficient resource utilization. Protocol architecture optimizes resources utilization, minimizing bandwidth consumption and reducing network congestion. So this optimizes the use of network resources and reduces congestion, right? So, the message is transferred from one layer to another, and there is physical interaction, and this one defines that physical connection between devices. There is a logical interface. This one defines the logical connection between devices, right? Then we have a protocol. A protocol defines a set of rules that a layer uses to exchange information with a peer entity. These rules mainly concern both the contents and order of the messages used. So also need to discuss the OSI model. And the OSI model, this is the Open Systems Interconnection model, and is a 7-layer framework that defines the network architecture, right? So one computer moves through a physical medium to the software application in another computer. So OSI consists of 7 layers, and each layer performs a particular network function. So OSI model divides the whole task into 7 smaller and manageable tasks. Each layer is assigned a particular task. Each layer is self-contained so that the task assigned to each layer can be performed independently. Right? This is a picture of an OSI model, and there is a physical layer, a data link layer, network layer, and these layers are responsible. These are responsibility of the network. Then the transport session, presentation, and application, this is the responsibility of the host, right? So you need to explain each layer, and to start by explaining the application layer. And the application layer provides services to end users, right? End user applications. It provides email, file transfer, and web browsing, right? So this layer is responsible for providing an interface to the application user, and this encompasses protocols that directly interact with the user, such as email. We are talking of file transfer and web browsing. When a user sends an email using a mail client, the application layer provides the email service, formats the message, and sends it to the recipient's email server. We move on to the presentation layer, and the presentation layer conveys data into a readable format. It provides data compression, encryption, and formatting. So this layer defines how data in the native format of the remote host should be presented in the native format of the host. A web browser receives a web page from the server. The presentation layer then formats the data, decompresses images, and decrypts secure data. Then we move on to the session layer. This layer establishes and manages connections. So it provides dialogue control, synchronization, and data exchange. So this layer maintains sessions between remote hosts, right? For example, once a user or password authentication is done, the remote host maintains this session for a while and does not ask for authentication again in that period. So a user logs into a remote server using a VPN. The session layer establishes a connection, manages the dialogue, and synchronizes the data exchange. Then onto the transport layer. The transport layer provides reliable data transfer. It provides segmentation, connection, establishment, and termination, and then there is flow control, right? So it provides segmentation, connection, establishment, and termination, then flow control. So this layer is responsible for end-to-end delivery between hosts. So a file is sent from a sender to a receiver using a TCP, which is a connect so we are saying that a file is sent from a sender to a receiver using a TCP, which is a connection-oriented protocol. So the transport layer establishes a connection, segments the file into packets, and ensures reliable delivery. So we move on to the network layer. The network layer routes data packets between devices. It provides logical addressing, routing, and congestion control, right? So this layer is responsible for address assignment and uniquely addressing hosts in a network. A packet is sent from a sender and a receiver across a network. So the network layer routes the packet through multiple routers to reach the destination. So we move on to the data link layer. This one ensures error-free, right, transfer of data frames. It provides framing, error detection, and correction and flow control. So this layer is responsible for reading and writing data from and onto the line. Link errors are also detected at this layer. So a router receives a data frame from a sender and checks for errors. If the frame is error-free, the router forwards it to the next hop. Then we move on to the last one, the physical layer. The physical layer defines the physical connection between devices. It specifies the physical means of transmitting data, such as cable specifications, wireless transmission frequencies, and network topology. So this layer defines the hardware, cabling, wiring, power output, pulse rate, right? So a laptop connects to a wireless network using a Wi-Fi adapter. The physical layer defines the wireless transmission frequency and network topology, right? So we also need to move on to the TCP/IP model. This one is a 4-layered framework that defines a network structure, right? So when you're talking of a TCP/IP model, this is a 4-layered framework that defines network architecture, and we're going to explain, right? The application presentation session is combined into a single layer. So also the OSI model focuses on the theoretical aspects of networking, while the TCP/IP model focuses on the practical aspects of networking. This marks at the end of our presentation, and if you have any questions, you are free to ask in the comment section. If you have comments, you are also free to comment in the comment section. So thank you for your attention. I hope this presentation has provided a comprehensive understanding of protocol architecture and the OSI and TCP/IP modules. If you have any questions, I repeat, please feel free to ask. Thank you.